All right, so we're looking at reflections today. So that's the next type of transformation. Previous to this, we did translations. So what is a reflection? Think about looking in the mirror. You see your reflection. Your reflection looks like it's the same distance away on the other side from the mirror. So that's what's going to happen when you do a reflection. We, in this course, are doing reflections in the x-axis and in the y-axis. You can do it about other lines, but in this course, that's what we're doing. So let's start with graphing these two functions. So go to your y equals. Okay, we're going to graph the parabola. So bracket x plus 2 bracket squared plus 1. And then we're going to replace y with negative y. When we do that, we need to solve for y. Okay, when we solve for y, in order to put it into our calculator, we really have to divide everything by negative 1. So that's going to be y equals negative bracket x plus 2 squared minus 1. Okay, so in our calculator, that's what we're going to put in. Negative bracket x plus 2 bracket squared minus 1. Okay, standard screen should be good for this. Examine the graph. So the first one, if you go on trace, it goes flashing on the first one you enter, the original, and then if you cursor down, that's on your image. Notice how it's the same size. Direction of opening is opposite. First one opens up, the next one opens down, and notice that the y value of the vertex in the original and the y value of the vertex in the image are opposite signs. You've changed the sign of y. So that's a reflection in the x-axis. So when you take your original and y is replaced with negative y, the new graph is the original reflected in the x-axis. Now the equation of the x-axis is y equals 0. Don't get confused and think x-axis, x equals 0. Remember back to your math 10. Okay, a horizontal line is y equals. Point 110 on the original. If we're reflecting in the x-axis, it's changing the sign of the y value. In general, that means it's changing the sign of y. And that makes sense. You're replacing y with negative y. Okay, so that's a reflection in the x-axis. Next one, now we're looking at a radical function. So now when we replace x with negative x, we're going to get negative x minus 2. You can put brackets around that. Always when you're replacing, you're substituting. In this case, it doesn't change anything. It's still going to be negative x minus 2. So clear your calculator. Go to y equals, clear, and then enter square root x minus 2, and then square root negative x minus 2. And then graph. There's your original. There's your image. Notice how they've been reflected. If you folded on the y-axis, they would overlap each other, right? So these are reflections in the y-axis. That's when you change the sign of x. So this is reflected. But it's reflected in the y-axis. The equation of the y-axis is x equals 0. If we've got the point 6,2 on the original and do this reflection in the y-axis, our new point is negative 6,2. In general, that's negative x, y. Okay. We're just changing the sign of those coordinates. So this is to summarize. If we're doing a reflection on the x-axis, sometimes we say in the x-axis, on the x-axis, about the x-axis, all means the same thing. Then we are replacing y with negative y. Okay, so they're never the same letter. X-axis, that's the horizontal. So when we do that, we get negative y equals f of x. Notice how we've put an or in there, because oftentimes we solve for y. And so the image point, then, we've replaced y with negative y. Reflection in the y-axis changes the sign of x, and so it's going to be y equals f of negative x. There's no way to show that in another way. You can't factor out a negative outside of f. We don't know what f is. And then, so that's changing the sign of x. Okay. Next one, we've got that radical function there. If is the equation for the function in terms of f of x or in terms of x? Well, I just said it's a radical function. That means I know what the shape is, so it is in terms of x. If it was in terms of f of x, I wouldn't know what the shape was. So it is in terms of x as I know the definition of it or shape of it. I can graph it on the calculator, which is a big hint. Point 14, negative 1 lies on f of x. So what happens to that after reflection on the x-axis? That's changing the y value. Okay, so the x stays the same, the y changes. Reflection on the y-axis, that changes x, but not y. Okay. Write the equation of the image after each reflection, and then solve for y. So in general, reflection in the x-axis changes the sign of y. So I replace y with negative y, and then y being isolated, just always be careful. Divide everything by negative 1. So that's going to be a plus 5 outside that. Reflection in the y-axis changes the sign of x. And in this case, I can put brackets. It's not going to change anything. And there's nothing to simplify. Okay, so invariant points, as I mentioned, we talked about them last year. It's a point that's unaltered by transformation. We're going to look for invariant points as we do these reflections, okay? So that's g of x. I'm going to complete the table. Just be quiet, please. Okay, and so domain and range of the original. So just look at the domain that's from -8 to +1. Again, it doesn't specify what form to use. If you want to use step builder, you can. If you want to use interval notation, or even if you want to use step builder but not do the whole squiggly bracket thing, then you could go just -8 to +1, and just be aware that on a test, when it asks for domain and range, you want to put the proper notation, right? It's just, we're saving space here.
Would you ask us for the step builder or?
We would, if we're particular to it, we'll ask for it, otherwise we should.
Okay, so otherwise, like, why would you ever choose anything other than wait for it?
Well, sometimes it's just nice. I like it.
Right.
Anyway, range here is from -3 to 6. Okay. Okay, so now we're going to replace x with -x. So that's a reflection in, so we're changing the sign of x, which means it's going this way. It's going across the y-axis. So in the y-axis, okay, so let's think about that. So start with each important point. So -8 for x becomes +8 for x, same y value. Negative 5 for x becomes positive 5. And I join them up as I go. This, I probably can't get it straight unless I do that. Okay, then 0 stays as 0. That's a hint, right? And then 1 there becomes negative 1. And let me just change the color of these. Okay, so you can see how it's reflected in the y-axis. The point that did not move, okay, based on this transformation, is this point here. So coordinates, there's just one that didn't move, and it's 0, negative 3. So you give the coordinates of that point. So what happens to the domain? Well, you can see what it is because we graphed it, but say you didn't have a graph, right? You were just given this domain, told to do a reflection. So the signs of these change, right? So this becomes positive 8, this becomes negative 1. But order matters, right? So positive 8 would then go here, 1 would become negative 1. And then x is between those. You always want to go from, yeah, change the sign and switch the digits.
Unless it's impossible.
Yeah, if you keep the inequalities in the direction of going to the right, which makes sense. You always want to think about the number line, right? You never put negatives on this side and positives on this side. Range did not change. Okay, next one is the other reflection. So reflection in the x-axis. Okay, let's do that. So this 6 becomes negative 6 for the same x value. Negative 3 becomes positive 3. I'm actually just going to do all of the points at once here. This becomes positive 3. And this stays. Let me just, actually, I'm just going to do my best to do a straight line here. Okay. So, the point that did not move is this one. Is there another point that did not move? Yes. Okay, it's this point here. I didn't physically look at that point, but if I did, right, where these intersect on the x-axis, that's invariant. So even though I wasn't looking at that one specifically, it did become. Okay. So that is negative 6, 0, and the other one's 1, 0. So in this case, the domain doesn't change from the original, but the range does. So even if we didn't have a graph, we change the sign of these. That would become 3. Put it on the right. This would become negative 6, which is smaller. Okay, and you can check from your graph, negative 6 to positive 3. Okay. So, graph those and turn over the page. So it's we're kind of being a bit repetitive, but that's okay. Bring it in your head. Okay. So actually, maybe you want to look back at the last one. So if we are replacing x with negative x, that's a reflection about the y-axis. Okay. So when we reflected this about the y-axis, we got the blue one. Where was that invariant point? It was on the y-axis. Okay, so any y-intercepts will be invariant when you reflect it in the y-axis. And similarly, when you reflect in the x-axis, then points on the x-axis will not change. Okay, so when you think about that, this, if it's located on the y-axis, you want to look for the y-intercept of your original function. Okay? If you're reflecting in the x-axis, you want to look for the x-intercepts. Now, these are all functions, right? We're using function notation. Yes, you can reflect and translate in everything for non-functions. We wouldn't use function notation, right? But you could still do it. In any case, we'll only have one here, right? Maximum, if it's a function. So now it says algebraically determine the exact value of the coordinates of the invariant point when this parabola is reflected over the y-axis. You did this last year, okay? So when we're reflecting over the y-axis, we're replacing every x with negative x. So here, do we need to do that though? Right? No, because all we're doing, if we're reflecting in the y-axis, is we're looking for the y-intercept of this graph. Okay, so we're looking for the y-intercept of the original. Well, y-intercept is when x is 0. And you don't even need to substitute, right? It's just the constant term. Okay? So it says the exact value of the coordinates, so we need to show this in coordinate form. So that's a y-intercept, so that's 0, -3. Okay, so don't do the reflection in the equation. Right? The whole point of it being invariant is it doesn't change, it doesn't move. So you just look at where are the points on the y-axis, in this case the y-intercepts of the original, because it's a function.
Yeah, if you didn't know that, you'd have to equate one.
That's right. And it would still work, but it's like a waste of time. And usually students make mistakes. Okay, so looking for the x-intercepts, that's when y is 0. Put 0 in for y. If you can't faster, you use the quadratic formula where it says memorize here. Can't faster, actually. It looks like you can, but you can't. And then simplify. Give it a few minutes to do that. coordinates. So those are the x values. So the coordinates would be -3 plus root 15 over 2 comma 0, and -3 minus root 15 all over 2 comma 0. Okay, if it says coordinates, then you've got to put it in coordinate form. Okay, and then 5 is basically what we did in the previous page chart, except in the general case. No numbers. Okay, so you're given the domain and range of some function. If we reflect it, okay, taking a look here, we're replacing x with -x, which is a reflection over the y-axis. Okay, so changing the x value, going over the y-axis. The y value doesn't change, so this would stay as that. But now, as we said, we change the sign, so a becomes -a. But if a is smaller, then when you change the sign of it, it will be the bigger. If b is bigger, when you change the sign, it will be the smaller. And then really, we have like that. So don't make the mistake in this general case of changing the sign and leaving them in that order. You have other numbers that as an example to help you if you need to. Okay, then this one is reflection in the x-axis. Okay, so now the domain isn't changing. But the range is. C becomes -c, D becomes -d. All right, so now we're going to combine the two reflections. Two transformations. Yesterday's translation, today's reflection. Order is important. Okay, so you have to do reflection before translation. Yep. Yeah.
If you think about it, because reflections were easy at this level, just multiply by -1.
Yeah. Okay, so let's take a look. This is going to show you that you can get different answers. Sometimes if you mess up the order, you still get the same thing, depending on what those transformations are, but sometimes you don't. So the point 32 lies on the original. Okay, listen. So if g of x is reflected in the x-axis, okay, so up here goes down below or vice versa, and then translated down with the image point. So translated in, reflected in the x-axis makes this become 3 -2, and then translated 1 down would make this 3 and -3. Okay. I sometimes go step by step in my math. Go up to it. Here, if we translate down 1 unit, that would be 3, 1, and then reflect in the x-axis, then we have 3, -1. Notice how they are different. Same transformations, but orders were different. Okay, so the order transformations were performed. Okay, so order is important. Unless stated otherwise, unless it's a question like this, where it says something and then something, okay, then you know you have to do it in that order. Always do reflection first and then translation. Okay, so again, another graph and another chart. Okay. So there's your f of x. Okay. Okay, listening please. Almost done. So here, original domain from 0 to 6. I'm just going to use interval notation. Okay. And then range would be -8 to -1. Okay. So when you're describing the transformation, put them in that order. Reflections before translation. So there's both here, but I'm going to put this first. If you are limited in space, just use R for reflection in this case, y-axis. Okay, because you're changing the sign of x. Then y was replaced with y -3, so vertical translation, 3 up. I'm going to graph it right now and then I'll fill in, or you can vice versa, but I'll graph it. So this point here, I'm reflecting in the y-axis, which doesn't change it, and then I go up 3. This reflect in the y-axis, which becomes -2, and then 3 up. Okay. This one reflect in the y-axis, becomes -4, and then 3 up. This reflect in the y-axis, becomes -6, and then 3 up. Okay, so it should look the same shape, but in this case, a reflection and a translation. General, so x has changed sign, and y we've added 3 to it. If you graph it, you can see what the new domain is, -6 to 0. If you didn't graph it, then for a reflection in y-axis, 0 changes sign, which doesn't change anything, and goes on the other end. 6 changes sign and goes at the beginning. The range, everything is moved up 3. So here, -8 plus 3 is -5, -1 plus 3 is 2. And you can check, -5 to 2. Okay. Notice here, nothing's been done to x. This is important that there's brackets. So when this equation was built, I'll do it over here. We started with y equals f of x. Okay, the first thing you have to do reflections first. So y was replaced with negative y, and then the translation, 1 down, y was replaced with y plus 1. Okay, in order to get that. If that didn't have brackets, and just was negative y plus 1, the reflection would, the translation would not be 1 down. It would actually be 1 up. Because the order of doing this, you have to do reflections first and then substitute in. So really, in order to get that unsimplified, that would have had to be a minus there. Right? We get rid of the bracket. So think about that. It's got to be factored out like that. That's going to be a reflection in the x-axis, vertical translation 1 down. Now, when you put it in mapping notation, x's don't change. Think about what happens. Reflection in the x-axis changes the sign of y. That result, now we're going down 1. So look, it looks different than this. It basically looks like the expanded form of this. We never, or rarely ever in mapping notation show it factor form. Okay, so nothing's been done to the x's, so this is going to stay at 0, 6. Okay. And you want to do these in steps? Then, okay, first of all, reflection in the x-axis would change, that range is from negative 8 to negative 1. If we reflect in the x-axis, those signs are going to change, right? It's going to become 1 to 8. Cut and paste so you don't have to listen and do that. This one here, let's finish it off and do this. Just watch. So, reflection in the x-axis changes this to this. Then I'm going down 1. So that's going to be 0 to 7. And maybe I should do it in green. So if I reflect this in the x-axis, that's positive 8. Down 1 is 7. This in the x-axis is 1. Down 1 is 0. Not straight, but close enough. Negative 3 to positive 3, down 1. Negative 2 to positive 2, down 1. So you can see it goes from 0 to 7. So this one, if I'm building that equation, I've got to be careful. You have to do reflections first. So if you are thinking that this is a reflection in the y-axis, you are correct. If you're thinking this is a horizontal translation, left 1, you are wrong. Okay? Just listening, please. Bianca, can you speak quiet while I do this? Okay? Guys? If you are thinking that's true, you are wrong. Because what that would be starting with y equals f of x, reflection in the y-axis, and then left 1 would be that. That's not the same as this. So always, if the negative is not factored out, factor it. So 2 sets of brackets. Okay? That will tell you what the reflection is, or the translation is. It is to the right one. Okay? So, mapping notation, reflection in the y makes that negative x to the right 1. So it does look like that, right? But this is the transformation form. Y doesn't change. So then domain reflects in the y-axis would be -6 to 0. Right 1 would be -5 to 1. And the original range stays. Okay, so careful on that. I should have done this in red. Anyway, here, so reflection in the y-axis doesn't change. Right 1 is there. Reflection in the y-axis goes to there, to the right 1. I'll be with you in a second, Mr. Walter. Reflection, -4 to the right 1. 6 to -6 to the right 1. Okay, so make sure state the equation of the transformed image in terms of g of x with y isolated. So you're starting with y equals g of x. Reflected about the x-axis is changing the sign of y. And then 1 unit right is x is replaced with, x is replaced with x minus 1. And then it says y isolated. So now that's in transformation form. Divide by -1. We get y equals negative g of x minus 1. Okay. Question 9, graph of y equals h of x is reflected over the line x equals 0, translated to left. State the equation again, so this is called h of x. Reflected over the line x equals 0 is the y-axis. Okay, so now we're changing the sign of x and translated 2 units left. So you're replacing x with x plus 2. Notice the 2 sets of brackets. So state the equation of the transformed image in terms of h of x with y isolated. It is. So I would expect that. Or you could actually simplify within the brackets. Either one of those. Okay. We are done that. Graphs of y equals f of x and g of x are shown. G of x is the transformed image of f. So we're always starting with f. How do we get to g? So write the equation in terms of f of x and then the math notation. So we're starting with f and going to g. So think about the shape. Is it exactly the same shape? Well, not really. There's been a reflection. So always want to do reflections first. So to me it looks like it's been reflected. And if you take a look here, sort of this part of it, it's 1 unit wide, 3 up, and this part of it here. So that is the same, but reversed. So that to me tells me a reflection in the y-axis. So if I were to do reflection in the y, I would get this, and then I have to go down and to the right. So this will be reflection in the y-axis, vertical translation, I'm abbreviating here, but vertical translation down 3, and horizontal translation right 1. Okay, so that will be, okay, so we're starting, I always start with y equals f of x, reflection in the y-axis, changes the sign of x, vertical translation down 3, replace y with y plus 3, and then horizontal translation right 1, replace x with x minus 1. Double sets of brackets there, and then write the equation of g of x in terms of f of x. This is our new function, right? Y equals f of, it doesn't say to simplify, so I'm going to keep the sort of the transformation form, and then minus 3. Okay, Okay, and so now this is your g of x. So you don't have to write it twice. You can just now call it g of x. Okay. Next one, so we're going from F to G. So again, looks like the same shape, a different orientation. Here, this V part is now upside down. So to me, that tells me I've done a reflection in the x-axis. So let me do that first. So -1 for y, +1. +2 for y, -2. -1, +1. -2, +2. It doesn't have to be perfect because you're not asked to graph, you're just asked to figure things out. And then now that moves over. So this point here has to move here to here. So that's 1, 2, 3, 4, 5, 6 left and 1 up. So that's a reflection in the x-axis. Horizontal translation 6 left. Again, this is not what I would want on a test. This is my short form. Vertical translation 1 up. So starting with y equals f of x. Actually, I'm going to start above that. You have the space, and they match up. Reflection in the x-axis changes the sign of y. 6 left replaces x with x plus 6. 1 up replaces y with y minus 1 in brackets. Now, to get y by itself, we've got to undo this. So divide by -1 brings the negative over, and then add 1 to both sides. And now I'm going to call that g of x. Oh, I forgot to do mapping notation in the last one. So for this one, same thing, same order. So x, y reflect in the x-axis becomes -y. Then 6 left, x minus 6. Then 1 up. Oops. Okay, you don't have to show the intermediate steps. That's your final one. Okay. Okay, so we'll go back and do that mapping notation for the last one. I'll just do it down here. So reflection in the y-axis changes the sign of x. Vertical translation down 3. Subtract 3 from y. And horizontal translation right 1. So you've already done the reflection, and then you have to go right 1. Okay. All right. So now we'll go to C. Okay, so we're going from F to G. And so this I can see it's opening up there and down there. So I'm going to do a reflection from F. So in the x-axis. So 1 becomes -1, -2 becomes +2, 1 becomes -1. This is kind of messy, but it doesn't have to be perfect. 2 becomes -2. Okay, take a look at it. Still not correct because it also has to be reflected in the y-axis. So now -3 becomes +3, -4 becomes +4, -5 becomes +5, and then -7 becomes +7 from here. And so then we're just going to the last 1 unit. So this would be reflection in, what do they do, the x-axis. Now, order of this won't matter, which you do first in terms of the reflections. And then horizontal translation, left. Okay, so y equals f of x. Reflection in the x-axis is -y. In the y-axis use brackets, and then solving for y, we divide both sides the negative in front of the f. You can expand the brackets inside there if you want. Now, that's called g, so I'm going to, we'll call that x. In terms of mapping notation, so reflections, you can do both of those at once, right? And then you're going left one. Okay. So remember that mapping notation is, if you look at the x's, it looks like the inside of the function notation expanded. This, if I expand this out, will be negative x minus 1. Okay, so that's C. Then you're asked to sketch here. So it says, sketch them and put a circle around any invariant points. So you may want to, up to you, convert back to transformation notation. Like if you wanted to, you could show this as negative y equals f with negative x. I don't think you really need to. I think you can tell both reflections happen here. And so for the order of those, it doesn't matter what you do first. So 0, 0, if I do the reflection in the x stays the same, reflection in the y stays the same. The origin is made up of 0. So if you're changing the sign, nothing changes. Right away, I can tell that that's an invariant point. Okay, I'll circle it in a sec. Next important point, if I take the x value, I need to change the sign of it to negative 4. The y value, I need to change the sign of it to negative 5. Okay, so this is going to go like that. Again, use a straight edge. I'm doing it quickly. Here, x is 6 becomes negative 6. Y is 3 becomes negative 3. Okay? It's really the same as a rotation in this sense. Rotating that 180 degrees about the origin, but that is a reflection of both. The only invariant point is this one. Next one, what's happening here? So this is a reflection first, a reflection in the x-axis, and then horizontal translation to left. Okay, so reflect in the x-axis, negative 3 becomes positive 3, to left. Negative 6 becomes positive 6, to left. Negative 4 becomes positive 4, to left. Okay, no invariant points. Next one, we've got here a reflection in the y-axis. And the +5 outside of f means a vertical translation 5 up. So, reflection in the y-axis, negative 1 becomes positive 1, and then 5 up. Positive 2 becomes negative 2, and then 5 up. I join as I go, so I know what points are what. Once you do a few transformations in one, it's difficult to know which points to join up. So go in order. Next one, reflection in the y-axis, so 4 becomes negative 4, and then 5 up. And then 6 becomes negative 6, and then 5 up. Okay. No invariant points on that either. Next one here, so there's brackets, which is good. So that's a reflection in the x-axis. It's changing the sign of y, and then vertical translation to down. Okay, so negative 1 for y becomes positive 1, and then 2 down. Stays there. Okay. Next one, the reflection, so negative 6 in the x-axis becomes positive 6, and then 2 down. Here, this is negative 2, becomes positive 2, and then 2 down. So it's kind of bigger on that one, remember, and steeper on that one. Now, this is an interesting one because it looks like there's an invariant point, right? That point right here. We did a lot of talking about this in the springtime, actually, and technically, that's not going to be invariant because with each transformation, it didn't stay. So this original point with reflection in the x-axis actually moved here to 1, then it moved back. So technically, that's not invariant. If under a transformation that stayed and then stayed again, that would be invariant. If after each transformation, it didn't move, that's invariant. So in this case, we might actually have it incorrect on our note sheet, okay? We called Alberta Education and asked them for their definition. So just be aware of that, okay? For exams, we haven't actually seen one where this comes into play in particular, but we'll talk more about that as we go through transformations all this semester. Next one, we need to factor out that negative. Okay, so now we are reflecting in the y-axis, and then horizontal translation to left. So reflect in the y-axis to the right. That's right. Negative 2 becomes positive 2, and then to the left gets you here. This point reflects in the y-axis stays, and then we're going to the left. This reflected in the y-axis becomes negative 2, and then we're going to the left. This reflected in the y-axis becomes negative 4, and then to the left. Okay. So, the only point that's the same is this one here. And again, it's the same as what I talked about. If I reflect that point in the y-axis, it goes here first before getting back to that. So it's not considered a point of, an invariant point. Next one, again, got a factor first. So negative bracket y minus 2. So this is a reflection in the x-axis and a vertical translation to up. So reflection in the x-axis, okay, and then 2 up. Reflection in the x-axis, and then 2 up. Reflection in the x-axis, and then 2 up. Okay, definitely nothing invariant in that one. So really important that you factor out the coefficient of x or the coefficient of y. In this case, negative 1 was the coefficient. You're done. Okay?